Welcome to KognitoKey. You know that invisible shield that protects pretty much your entire digital life? Well, today we're going to pull back the curtain and see exactly how it works.
I mean, just think about it. From sending a quick private message to logging into your bank account, our lives are just full of secrets online. We share this stuff constantly, just trusting that it's all protected. But have you ever stopped to wonder how? Like, how exactly are they kept under lock and key?
So in this explainer, we're going to dive right in. First, we'll talk about our digital world's guardian. Then we'll get into what AES actually is. After that, we'll peek inside the encryption process, break down the 4 secret steps it uses, and finally, we'll wrap up with its biggest strengths and a really important warning. So let's start with our digital world's guardian and the problem with those old, outdated digital locks. It really begs the question, why did we need a brand new, much stronger lock for our data in the first place?
Well, before what we have now, the digital world was using an older standard called DES. And honestly, it had a huge flaw. Its key was just way too short. As computers got faster and faster, DES basically became like an old, rusty padlock. You know, the kind a modern thief could just pop open without breaking a sweat. It was pretty clear we needed a new guardian for our growing digital universe.
So what is AES? Let's define this modern standard. The solution that came to the rescue is a little 3-letter acronym that you probably use every single day without even realizing it. AES.
Okay, so back in 2001, the U.S. National Institute of Standards and Technology, we just call them NIST, made it official. The Advanced Encryption Standard was the new kid on the block. Now, it's called a symmetric block cipher. I know, that sounds super technical, but it's actually pretty straightforward. It just means 2 things. 1, it uses the exact same secret key to both lock your data and to unlock it. And 2, it works by chopping your information into fixed-size chunks or blocks.
And this is where we see a totally new approach. See, the old way, TES, was a bit clunky. It would split a block of data in 2, and then kind of use one half to mess with the other. But AES, it's so much smarter. It takes the entire block of data, the whole shebang, and works on it all at once as one single unit. And that makes it way, way more efficient.
All right, let's go inside the encryption process and look at the core mechanics. So how does it actually scramble your data to make it completely unreadable? Well, the real magic happens inside a series of steps that it just does over and over and over again. We call them rounds.
So, AES grabs a 128-bit chunk of your data, your plaintext, and arranges it into a neat little 4x4 grid. Now, how secure this all is comes down to the size of the key you use. And it's pretty simple, really. A bigger key means your data gets put through more rounds of scrambling. So, a 128-bit key gets 10 rounds, but a super strong 256-bit key, that goes through a whopping 14 rounds. The formula is easy. More rounds equals much more security.
Now for the really fun part, the 4 secret steps. Let's take a look at the transformations that happen inside every single one of these rounds. So what exactly is going on in there? Well, every round, except for the very last one, involves 4 distinct steps, and their whole job is to completely and utterly mix up your data.
These 4 functions, they are the absolute heart of the AES process. You can think of it like this. 3 of the steps are all about swapping out the data to create confusion, and the other step is about shuffling everything to spread that confusion around. It's brilliant. Let's break them down. Okay, step 1, substitute bytes. Imagine you have a secret decoder table. That's kind of what the S-box is. In this step, every single byte in that 4x4 grid gets looked up on this table and is swapped out for a totally different one. The whole goal here is just to cause chaos, making it almost impossible to see any relationship between your original message and this newly jumbled text.
Next up, step 2, ShiftRows. Now the bytes get a really good shuffle. The top row, it stays put, but the second row gets nudged 1 spot to the left. The third row moves 2 spots, and the last row shifts 3 spots over. Why do this? It's absolutely crucial for spreading the data out. It takes any patterns that might have existed and just smashes them to pieces.
And just when you thought it couldn't get more mixed up, we have step 3, MixColumns. Seriously, you can think of this like putting each column into a mathematical blender. Each of the 4 columns is put through this special function that completely transforms it. It's another powerful way to spread everything out, making sure the data is as scrambled as humanly possible. And finally, we get to what is arguably the most critical step of all. Step 4, AddRoundKey. This is where your secret key actually comes into play. A unique piece of that secret encryption key is combined with our data grid. This is the only step that uses the key directly weaving it into the data itself. This is what makes the encryption totally unique to your key.
So this whole four-step dance, it repeats over and over again, 10, 12, or 14 times. But here's a cool little detail. On the very last round, it skips that MixColumns step. And there's a really good reason for that. It's what makes the whole thing reversible, so you can actually decrypt the message later. After all those rounds are done, what you're left with is the final, incredibly secure ciphertext.
All right, let's talk strengths and a warning. Now that we've seen how this thing works, what actually makes AES so powerful? And, more importantly, what's the one huge warning you have to remember when you're dealing with it?
Well, AES is just incredibly versatile. You can run it on tiny little devices, but it's also strong enough for top-secret government data. Its flexible key lengths and the fact that it's used everywhere make it the true workhorse of modern security. But, and this is a huge but, there's a catch. The entire strength of this complex system hinges on one thing: the secrecy of the key. If your key is weak, or if you don't store it properly, well, that unbreakable lock becomes completely useless.
And that really is the key takeaway, isn't it? AES is this amazing, invisible guardian watching over your data day in and day out. But at the end of the day, that guardian is only as strong as the key you give it. Managing that key properly, well, it's everything.
You know, this brings us to a really big question for the future. AES is the king of encryption today, for sure. But computers are always getting faster, and we have things like quantum computing right on the horizon that could, in theory, break our current standards. So what's next? What will the next generation of our digital locks even look like? That's a huge challenge for the cryptographers of tomorrow.
If this helped you unlock the world of AES, we'd love it if you'd subscribe to our channel, KognitoKey. We've got a lot more explainers like this one coming up.
And of course, don't forget to give this a like and share it with anyone who's curious about how our digital world really works. Thanks so much for watching.